So I'm back again in Oxford at the University of Oxford, speaking with a very interesting atmospheric physicist, planetary scientist who is a is it a co-investigator on one of the instruments of ESA's, the European Space Agency ExoMars Trace Gas Orbiter. Kevin Olsen, is that how you phrased yourself in terms of your association with TGO?
Yep. Hi, I'm Kevin Olsen. I'm a research fellow at the University of Oxford. I'm a co-investigator of the ExoMars Trace Gas Orbiter's Atmospheric Chemistry Suite instrument, studying the composition in fine detail of the Martian atmosphere.
And the TGO, the main thrust of the mission was to try to find methane. Is that right?
Yep. The primary objective is to find any trace gases that can tell us about whether or not there are or have been active geologic processes or biologic processes. Methane being one of those.
And you were just telling me in the interview, and I said, let's use this for the video, that if methane, if Mars ever had methane, perhaps it's from a dead biosphere, correct?
Yep.
And what do you mean by that?
So what I wanted to parallel that with is if it's not. So if methane is coming from organic material, from like a biosphere, then there's either things that are living that are producing methane as they sort of go about their daily life and use energy, or maybe they're not living anymore and there was an ancient one and there's still chemicals underground that represent them and could be seeping out. If methane is not coming from a biological source, then the most likely thing is active rock metamorphosis. So this is where rock is changing from one type into another, and this would happen deep underground where the environment is warm, it requires liquid water, and it's producing chemical energy. And so if you have deep underground, high pressure, not wet water, but lots of water, lots of heat, lots of energy, hydrogen is being released by these reactions, that's the perfect place to start finding life. So even if it's not direct evidence of biosphere, it's where we would expect there to be a biosphere.
But after 8 years of observations and all your instruments on TGO working at nominal levels, you have not found evidence for methane.
Nope. We have sensitivity at all altitudes in the atmosphere of Mars, all over the globe, 1,000 times better than the Mars sample analysis suite on the Curiosity rover, but we do not see any sign of the absorption of methane the absorption of sunlight by methane in the Martian atmosphere.
And what's your explanation for this non-detection of methane?
Well, the simplest explanation is that it's not there, but we are working really hard to reconcile the observations made by other teams and other instruments with ours, but we haven't done it yet.
So let's just kind of give an overview. The first question I asked you in the interview was, what has changed in the last 50 years in our understanding of Mars's atmosphere? And then we kind of ended our interview by saying, well, it depends on who you ask in the scientific community whether Mars was habitable 3.5 at 3.5 billion years ago. Is that right? During the Noachian phase, where it was, some people posit that Mars had an ocean, deltas, maybe microbial life.
I mean, they have those.
I'm sorry?
They have those. We see the water features.
You see the water features.
There was a lot of liquid water flowing around on Mars before.
Finding biosignatures or hints of past life on Mars has been a lot more difficult than people expected, than Carl Sagan probably even expected, right?
Before our mission started, there were already people that didn't believe the past methane observations. And there were basically people were really sort of siding into two different camps of whether or not we will find methane and confirm methane or not.
But methane could be abiotic as well, right?
Yeah, but without methane, then we're really back to square one. And the next thing that will really tell us what's going on will be the drill on the Rosalind Franklin rover,
which launches in 2029 and is taking the long way to Mars, a 2-year trajectory.
Yeah. So we'll be hearing news from the results in about 2032. And at that point, we'll be planning the next missions to Mars. Well, we're already planning them, but we'll be preparing them as well.
Right. And so you're not giving up on past life on Mars. You're just, you're not as sure as some people.
I haven't even given up on methane yet.
Okay. All right. Well, thank you so much, Kevin. Thank you for your time today. A fascinating interview, and good luck with your future research.
Thank you.